Today we're going to solve a double binomial. So this is similar to the last video where we solved for a simple binomial. But in this case, we have two x's. We've got one x here, one x here. However, x is an x. Okay? It's like saying 1 equals 1. X equals x. Doesn't matter what x is. If x equals 4, we know that we can write this as 4 because x equals 4, and we can write down x equals 4, so therefore 4 equals 4. So x is the same in this situation. Okay, so let's break this down a little bit. We want to have the x's on one side and the constants on the other. Currently, we have a constant on either side, a constant term, like we talked about in the last video. This is a constant term, this is a constant term, and this is a expression with an x in it, and this is an expression, a term with an x in it. Okay? So we want to get all of these green ones on one side and all the blue ones on the other side. So let's write this out one more time, really big. 7 minus 3x. Let's start that again, make it a little bit nicer to read. 7 minus 3x equals 4 plus 9x. Okay, so let's start by trying to move all of the x terms onto one side. So to do that, you could either go to one side and subtract 9x and do it on the other side, or in this case I'd rather choose, because I know there's a negative here, I'd rather, just to make my life simpler, add 3x to this side, and if I do it to one side, we need to do it to the other side. Okay? So we're going to start by doing that, because then this cancels with this, and all we're left with on the one side is 7. Nice and simple. On this side, though, we have a little bit more of a mess. 4 plus 9x plus 3x. Okay, well, 9x plus 3x, well, we can, because they both have x in their term, we can add them together. So that's 12x, and so that's just these two terms coming down. And let's subtract 4 from both sides. Like that. Okay? The reason why I'm doing that is to get rid of this 4 with this 4. Okay? Now we have, on one side we have 12x, and on the other side we have, I'll switch those around, 7 minus 4. Okay, because we just subtracted 4 on that side. Now, if we do this, 7 minus 4, everyone should be able to do it by now, 3 equals 12x. And now we divide by 12 on both sides. Actually, let's go with red pen so we can see what we're doing. Divide by 12 on both sides, and that comes down to be x equals 3 over 12. So this 12 and this 12 cancel. Alright, so there's our simple binomial equation. Or slightly more complex, but still pretty simple. Let's look at it in terms of physics. Alright, here we're going to look at a physics example of the slightly complex binomial. Okay, before we even start looking at the question, we begin to look at where are our missing components. So a worded question might say something like, mass 1 is 5 kilograms and mass 2 is and the acceleration is 1.2 meters per second squared. So what is mass 2? Something like that. So you write down what you know, and I'm just going to try to do it in different colored pens just so we keep things clear. So acceleration will be in green, mass 2 in red, mass 1 in blue. Okay, now from this diagram, we can see that mass 2 is accelerating up, mass 1 is accelerating down. So mass 1 has a Fg1 that is bigger than its Ft1. And mass 2 here has a Fg2 bigger than its, smaller than its Ft2. Okay, does that make sense? So if its Ft2 is bigger, it's going up, and if this Fg1 is bigger in blue here, then it's going down. Okay? So because we know that it's accelerating towards mass 1 and down at mass 1, I'm going to write the classic physics, two physics things, the Newtonian mechanics. F net equals m net A, and I'm going to write the other one, which is where this is going to start coming into effect. F net equals F1 plus F2 plus F3 ... to infinity. Okay, now this F net, in this case, F net is Fg1 from here, Fg1, okay? And if we're going to be really meticulous, we're going to start writing all of these other forces. So there's a Ft1, so if we wrote that over here, we'd put Ft1, and since it's the opposite direction as this force of gravity, the opposite direction, so you add vectors, how? Tip to tail. So if we start here, it goes like this. It goes down first, then it goes up, like that, something like that. Then we add, we bend the pulley around. So if we imagine this as being on a plane here, so we've just bent this. So now we can do the same thing on this side. So our Fg2, is that in the same or different direction as Fg1? Well, if you imagine, if you look along the string, going up the string, back down the string, well, if you went up the string on the M2 side of things, it would be the same as going down the string on the M1 side. So they're inverse. So when I write Fg2 compared to Fg1, we're going to put negative Fg2. And we are going to put positive because our tension is in the opposite direction as our gravity, Ft2. Okay, now looking at these, I'm quickly remembering that tensions on the same string, when pulled two different directions, these actually just cancel. Okay, so we have F net equals Fg1 minus Fg2, which is really similar to what we have at the beginning here, right? It's the one side. So now, this is the trick that you can do for any equation in physics. And if you don't know how to do this, and this isn't making sense to you in this video, please check out my equating equations video. So that's what we're about to do here. So this fnet is equal to this fnet. Okay, take a look at that other video if you don't understand this next step. Mnet, bring this one down, A equals FG1 minus FG2, okay, from the right equation. Now splitting up, if this says Mnet and this says Fnet, Fnet we remember was F1 plus F2 plus F3, so net means just the addition of all of the different types of that thing. So force net means the addition of all the forces in a system. Mnet means the addition of all the masses in the system. So here we can write, instead of Mnet, we can write something else. Well, what are all the masses in the situation? Just M1 and M2. So looking back down here, we can write M1 plus M2. Looking pretty good. And on this side, we're just going to stay the same for now. Fg1 minus Fg2. And I'm just going to write off to the side here the equation that we know for gravity. Fg equals mg. And this is just an equation that you have to memorize. G on the planet Earth equals 9.81 meters per second squared. This is just a known equation that will be on pretty much any data booklet or equation sheet, formula sheet. So that you don't necessarily have to know, but you have to know how to use it. And it's not that complicated. You'll probably end up memorizing it whether you like it or not. Okay, so now we're going to do the same thing as we did before, equating equations. Here is Fg equals mg. We're going to do that for the Fg2, and we're going to do that for the Fg1. So let's look at this. It's m1 g1. I'm going to keep this side the same, actually. Plus, there you go, that side's the same. Oops, sorry, not A there. M1. Okay, there you go. Now that side's the same. Okay, looking back on this side, we have, again, equating equations. So the Fg2 becomes M2G. Now, we want to get the red M2s all onto one side, because we know all of the other values except for the red values. I'll just write this G as that because this G is a constant. We know that value. Okay, so what we're looking for is all of those red things to be on one side. All the M2s, all of the unknowns in this situation. To do that, we can go about it two different ways at this point. One of them could be taking this term and trying to get it to this side, or we can start trying to figure out if we can get this M over to this side. I'm going to start by expanding this out. Okay, so currently we have this A here. I'm going to multiply it into the brackets. Okay, so A plus A, M1, M2. There you go. Does that look right? I just added A in front of both of those two. I just multiplied it into the brackets. Equals M1G minus M2G. Okay, so now we have two nice looking terms, like we did before for the double binomial, that have our unknowns in it. Everything else is known except for the m2, which is in red. So now we want to move it over, and basically all we do is we add. If we want to add to this side, if we want to move this one over to this side, to the left side, then what we can do is we can add its same term to both sides. Okay? Or if you want to do the opposite, you could, because this is addition, you could subtract it from both sides. So addition and subtraction are opposites, and we'll see in a second division and multiplication are opposites. Equals. There you go. Now we're going to write it back out again so that we can see how our equation is looking. m2g plus a m1. I'm going to stop writing the m1s because we already know what it is from our question up above. I'm going to write this one over here just because run out of room here. Actually, just to keep it in the same order might be nice, eh? Plus a m2 equals, and what did we cancel out over here? Well, we canceled this one with this one, right? So what do we have left? Just this first term, so m1g. Okay, that's pretty close to having all the constants on one side, but let's look and try to get this term now onto this side. Okay, well, to do that, we just subtract it by both sides. am minus am1. Okay, so we're subtracting from both sides. So this is m1g minus am1. Looking pretty good. A plus g here. Okay, so I'm just writing it out now that we've canceled out this part and this part. Just taking the two equations, this one and this one, bringing them down. Okay. And now we have all of our constants on one side, all on the right side, and we have all of our variables on the left side. That's pretty good, but our variables have a couple little minor constants by them, okay? So let's try to get rid of those. Well, remember how earlier we took a and we put it into the brackets? We're going to do the opposite here. Instead of multiplying it into the brackets, we're going to factor out m2. Okay, so we're wanting to get this type of thing, right? But looking back up here, comparing to this, let's try to do it in the inverse. So if you don't believe me that this step works, take a look at this. If we write it out, m2 a plus g, and we, instead of taking it out of the brackets like we did here, let's put it back into the brackets, like that. Now we'll get m2a plus m2g. This looks awfully familiar. Oh, right, we did it right over here. So that verifies this equation, and we're going to keep going. So this is equal to m1g minus am1. And then how do we get rid of this little constant term? Well, if we have a constant times a variable, we can just divide one of the two, right? So we divide both sides. If we do it to one side, we have to do it to the other. Can't just get rid of it. And this guy will cancel this guy. So we have left m2 equals m1g minus m1 over a plus g. There you go. And here is our final answer. So you could now start putting in all these values. So we have m1, we have g, we have a, we have m1 again, same thing, we have a and we have g. So we can just plug in these values and get the answer for m2. So if any of these steps didn't make sense, please take a look at some of the other videos I've made, especially the most common mistake, I think, and the hardest step to understand is this step here, the FG equals MG. Actually, I'll highlight that. So if you don't understand that step and then plugging it into this equation, and if you don't understand how this FNet and this FNet relate, then you need to take a look at my equating equations video, and hopefully that'll make a little bit more sense. So that's our physics example. Hopefully it makes a little bit of sense to you guys.